Yesterday, we determined how we could measure the speed of light inaccurately by Galileo's experiment, and then significantly more accurately by the Michelson rotating mirror experiment. I mean, you got to understand that there's thousands of experiments that have been performed to measure the speed of light, many of which are terrible, many of which are very good. We talked about two yesterday. One bad one, one good one. Let's assume, though, that we now have a relatively accurate value for the speed of light. We're going to use that value for the speed of light sometimes to do relatively straightforward speed, distance, time calculations. I got one example for you here where we're going to use that speed that we determined yesterday to find something else. The question says, this is from Calgary to Regina is 800 kilometers. It's about 800 kilometers. How long does it take light to travel from Calgary to Regina? And if the wavelength of the light is 600, what is this? NM. Nanometers. What is its frequency? So what do we got here? We got a distance from Calgary to Regina of about 800 kilometers. We're going to call that delta D distance, although we're going to convert that to meters. 800, we could say 800,000, or we could just tack on a 10 to the 3 to replace the K, right? 800 meters. Well, instead of having kilometers, we'll just say times 10 to the 3 meters. Or you could say 800,000, whatever works for you. What do we got here? The wavelength is 600. Wavelength is 600, well, nanometers. But this is where I definitely don't want to start moving the decimal place over. You know, this is where I definitely want to look at the prefix on my data sheet. Everybody do that right now, actually. Look on your data sheet. Not on the side that has the equations, but on the other side of the data sheet. What's a nano? Yeah, Justin, what's a nano? 10 to the negative 9. So don't make it like 6 times 10 to the minus 9. Make it 600, and then just replace the n, the nano, with 10 to the minus 9. Now, that's not scientific notation, right? But that's okay. It's not a final answer. 600 times 10 to the minus 9, 6 times 10 to the minus 7, 0.000 whatever works for you, but this is what works for me. We want to find the time that it takes light to travel that far. We want to find the frequency. Is there anything else that I have given to me here? If I read between the lines, that is? Yeah, we have the speed of light. It's not technically a vacuum between Regina and Calgary. It's filled with air, but the speed of light in a vacuum is only ever so slightly faster than it is in air. So although we're given the value for the speed of light in a vacuum, we can assume that the speed of light in air is the same value. 3.00 times 10 to the 8 meters per second. Now, when you get into something like glass or water, it slows down dramatically. But in air, it's pretty much the same as a vacuum. By the way, I've left a space there. I've said V equals, on your data sheet, it says, what symbol does it give you for speed? Look at the data sheet for the constant for the speed of light. It calls it C. We call it V if you want, because that represents any speed, but C specifically represents the speed of light. So you want to use V, go ahead. You want to use C, go ahead. But just recognize if you ever see C, if you ever observe C, what it means. Okay, it means the speed of light. All right, what do you want to do here? What do you want to do here to find either time or frequency? Sorry? Get T. Okay. Okay, you're on the hook now, Austin. How would I go about getting T? Sure. Why not use V equals D over T? D over T or delta D over delta T, however you want to write it. Rearrange that to solve for T. The distance that it travels here is 800 times 10 to the 3 meters. The speed, or the velocity, is 3.00 times 10 to the 8 meters per second. Let's figure out what that is here. 800 times 10 to the 3. Divided by 3.00 times 10 to the 8 gives me a time of 2.67 times 10 to the minus 3. Now that's a pretty small time, right? But if light can make 25 or 30 return trips across Canada in 1 second, well, it's not going to take very long to go to Regina. What about frequency now? Is there anything else that we can do to find frequency, or are we at a little bit of a loss here? Yeah, Cameron?
T equals 1 over F.
Well, you could say T is equal to 1 over F, but remember that T is big T. That's the time for one complete cycle. And I don't know what the period of this is. If I knew the period, I could use that. It's certainly a valid equation, right? That?
We multiply the time by 2 to get the distance back.
No. If you multiply the time by 2, that's going to be the time to go there and back, and you could get the distance there and back, but all you'd have to do for that would be to double that distance, right? That doesn't represent the wavelength or the frequency per se. Yeah? Yeah, that's exactly what we're going to do. V is equal to F times lambda. Remember when you're given a wavelength and you want to find a frequency, you use V equals F times lambda? It's exactly what we do here, right? Like if this question said, what type of EMR do you have, you would calculate frequency and then compare it against your table. So let's do that. Let's say 3 times 10 to the 8 meters per second, divided by the wavelength, which is 600 times 10 to the minus 9. I believe when we do that, it works out to be 5.00 times 10 to the 14 hertz. Now, what type of EMR is that, even though you weren't asked for that in this question? Kathleen? No, I thought you were mouthing it there. No? What is it? It's visible light, right? 10 to the 9 to 10 to the 12 is microwaves. 10 to the 14 basically is visible light, specifically 4 to 7.5 times 10 to the 14. And then 10 to the 17 to 10 to the 19 is X-rays. Anybody want to take a guess at what color that would be? That's not usually a big deal for us, but it's probably in that orangish range. I don't know for sure, but I'm going to guess orangish, yellowish, probably in the orange range. Would be my guess, yeah. But that is a bit of a guess. All right? All right, let's have a look at worksheet number 15. There's 5 questions on that worksheet. I'm going to give you a break this weekend, though, and I'm only going to make you do questions 1 to 4 on that worksheet. Plus practice question set number 20.